example in Rust and just do a quick introduction to some of the functional capabilities of Rust. So just for a point of reference, Rust is a very low-level language with some high-level functional capabilities. I think it's technically classified as a functional language, even though it is multi-paradigm. And in that way, it's almost a wolf in sheep's clothing. It's a low-level language with a lot of high-level features. Maybe you could think about it the other way around as a higher-level language with low-level features, but either way, you can kind of meet in the middle if you're a low-level dev that wants to explore some functional stuff, or if you're a high-level dev trying to go down more to the hardware level, get some more performant, statically typed code. So it's really great for either path, and it's got some really good abstractions that I'll go over. So closures are essentially the encapsulation or the enclosing of some outer state, and it's accessing variables outside of a function's local scope. This is also referred to as lexical scoping, and it's where Clojure gets its name, Clojure being the Lisp-based language, or the Lisp-style language on the JVM, and closures are only in very cool, functional, hipster languages, which I think Rust can say that it's a member of. So here's what you usually see in most languages that can implement closures or have higher order functions, where we're returning a function, which was a higher order function. So here we're returning something that implements fn mute, and that function returns an I32 signed in. And we have this other function hh defined to do just that, return an I32, and we return it right here. But you'll see that Rust has its own design pattern for implementing closures, and this is not something that we can do in this, even though in Python, Golang, Ruby languages like that, you're more likely to see something like this. You can see here, it tells you to use the closure form. And one of the great things about Rust is the compiler kind of almost suggests, pushes you, helps you along as you kind of fine-tune your code to get it working if you're having some trouble. So let's go here. So what you actually want to do here is you want to define this closure, and you want to use the move keyword. And what that does is it takes ownership of this GG variable, so it kind of reaches out of scope, grabs ownership of that, increments it, and then spits it back out. So now we have this function defined as a closure instead of defining it as a function, so it's a bit more verbose or a bit more specific. And then we pass this closure, because that's what's returned here, into the mutable ff variable. And here we just increment it, and we can see that we will get 1, 2, 3 as it goes. Just to show that that's working, I'll paste another one. There, 1, 2, 3, 4. So that state of ggx, which is saved in gg, is incremented and it's maintained as the program's running. And that's just one of the many functional features that Rust has. I'm still very, very green with Rust, and I'm just kind of learning as I'm going along, but this kind of archetypical closure example is one thing I wanted to try to implement myself, and I learned a couple neat things about how Rust handles and defines closures along the way.